Hello everyone. Today we will look at how to use how to basically deal with the NA values. This I have been learning machine learning and following the textbook by Aurélien Géron. The book is like hands-on machine learning with scikit-learn and tensorflow. So these are some of the things I have learned. And so just to refresh my memory, so we have the data set. So we'll say import pandas as pd and maybe and numpy as np. So we can we have previously seen how to divide the data set into a test and a train set. And so for example, so let us read the data. So you can say df the whole so we can call it this is data frame. So data frame is pd dot read csv data dot csv, and so we have this is the housing data that we have from the book. And so here when we look at, so let us first of all split this. So how do we split? So we have so if you look at data f dot index, right? So all the index values, let us take that and maybe cast to a list. So we have all these values. So let us rearrange it using so we take this, maybe save it as we can call it as index list or something, and then so we have indl. So if you use so we can use we can shuffle it, we can rearrange that list using randomly shuffle it. So how do we do that? Numpy dot random dot shuffle, right? So now if you look at indl, maybe, so you can see that it's already messed up. so what we do is we are going to keep maybe say, so if you look at the length of indl, it comes to be that much. So I can go and do maybe 20%, right? So that is that much. So we'll keep as a test set say test df equal to df so test df equal to so we have so our data, so data f, right? So data f so we'll take as a test df 20%. So it's called data f, and I take up to 4128, right? Maybe copy that. So I have test df, we don't want to see that at the moment, and then rest will be train df. So train df will be so I can take data f, my god, what a name, strange name I put, right? So we have our train df. Now so when we look at the train df, columns, right? So this is our the target value for machine learning. So we can if you want, we can keep it away just by so we can drop that column. So if I say train, I can create my target df, or it's not a df, or target basically the target the target series. So we can create that. So it will be train df dot median house value, right? Dot, we can just copy that, and then we can say train df dot drop, and say we can say which column. So we can say columns equal to the column that we want to drop basically is we don't want this anymore in that house value, and in place equal to, we say in place equal to true. So now the train df dot columns, so we don't have median house value, we removed it. That is a target value. So now when we look at train df dot a number of na values, we see that every column, almost all the other columns are okay, but the total bedrooms is 170. So we can do the same thing that we did, right? We can take our train df and just say train df dot drop, right, columns. Let me just for the because okay, now I can just train df dot drop, right? We can do the same thing that we did. We'll just say drop columns, and we need to just say the column, which column we want to. The column name is total bedrooms. So we can say that to just drop that particular column. And if you look at now is na sum, what we see, so we don't have any more for na because the na was coming from the total bedrooms label. So we removed that particular column. So that is one way of dealing with na. Or also we can also say, we can otherwise we can take train df, right? We can just we can say drop na, right? So here it will, rather than removing the whole column itself, we just totally losing it. We see that we have around 170 na values in that particular column. So we'll remove those rows from that particular. So that particular column, we don't remove the whole. We don't just check the whole thing. We'll just remove only those rows in that column where the na values are present, where the na values are not defined or empty. So here the default is axis 0, which is the row. So that's what we are interested. We are going to remove the rows for the subset, right? For the which column. That is, so we can write drop na, and we say what we say. We say axis you don't have to say because the default is 0. The rows, remove those rows, subset equal to total bedrooms, right? I believe that is right. So again, we can is NA. So now the total bedrooms are still there, but we haven't removed it. We just removed those rows for where there are NA values, NA. So now that is another way. So we have drop and we have drop NA. So two things we have seen. So another thing would be we can also do fill NAs. So we say train df dot fill NA. So again, so we have here, we can put the value, which value we want to put, and it will fill in this particular case we can directly write, say I want to fill with 0, I can do it. And if you look at is NA sum, so we already filled with 0, so it's already gone. So but this is working also because we don't have any other NA values anywhere else. Means in no other columns has NA values, so it won't just fill everywhere with 0. So rather than doing that, we can also we can do in a different way. We can say, for example, fill NA, right? We say total bedrooms dot fill NA with 0. So now we are filling that particular column with NA, and we can also, instead of doing that, we can also say median value of, say, train df, right, total bedrooms dot median, right? So we calculate the median value of that particular row, and then we can fill it with that. So say train df with the value, we can say the median, right? And if you look at one of the things, right, we say all these methods have this in place, so we can say that we can replace that value with we can say in place equal to true, means change the df in place and replace that train df change the values in the df with the median values. We can change it in place too. So now so these are the ways we can do. Instead of doing all this, we have also use the imputer. So we can say from sklearn, we can say sklearn, or we can input the simple imputer. So what we can do is so we can create so if now, before doing that, let us df test df, so test df, right? So we are train df. So if you look at train df and train df, if you look at columns, right? And if you go and look at columns, for example, train df dot, if you look at train df and df types, right? So we see that there is an ocean proximity that has all other ones are floats, and this one is actually, if you look at what do you call ocean proximity, right? First, we get my first thing. So you see that is that one is coming as a string. So let us keep that away and work with the rest. So for example, if I say df, so without what? Without string, right? String, this maybe we double without, yeah, without string, string without string will be, we can just drop that column to string df dot drop, right? We just drop which column? We'll drop columns equal to, we take that ocean proximity, right? And again we copy that one. So now df string, right, dot d types. So now we have only those columns, so we have only numerical values in the df. So now we can basically tell, so we what the way that from the, so we imported this already. So I have imputer, right? Is I create an instance of imputer. So let us look at a simple imputer. So if you look at that, so you can say that here there is the strategy. It says main. Suppose if I want to fill the NA values with main, so let's, instead of that, we can also go down. We have strategy, also we have a median. So we can, let us see, we can use that. So create an instance of that simple imputer and say strategy is median, right? And now I can say im dot fit. I can fit what we have. So the train df, this guy, right, without the string thing. I take that. So now it's already knows. Now the imputer, if I take imputer dot statistics, you see it already knows the median values of each columns. So this one you can also verify. You can say train df dot string median dot values. So you see that they match. So now the train df without string, it already knows about the median values now. So now our job is very easy. So we can just say imputer dot transform. What we want to transform is train df, this guy, right? So it gives us an array. So basically it changes the df and replaces the value of that with the median values wherever the NA values are there. It checks everywhere, so it will fit with corresponding median values wherever NA values are there for a particular column. So now we already lost our headers. So we have now I called, suppose this is an array equal to, I take this guy, so we get this array of all values, right? I call it as array. So now we can construct back our dfs. Maybe I don't know, df, we transformed df, means after fitting. So we can, how do we create? Just create a data frame, right? Just create a data frame, and we just pass the array, right? Matrix, we pass the matrix, and we can create. So transform. So if you look at it again, let's see. So see, we don't have any more the transform def. We have no more NA values. So, but if you look at def trans dot columns, or just let's look at the whole thing. So this is, so we lost the column names, so we can just pull up from def trans f, right, dot columns equal to def, so test train def. This is the one, right? This one, yeah, without string dot columns. So now def trans f. So you see, we got back the actual transform df. So this is a df without any NA values. We already filled with the median value. So we have seen how to clean up the data. So we can we only dealt with the numerical attributes. So we have we use drop NA, fillna. Any data frame you want, you can always look at, take the help, and you could perform, and just if there is a confusion or anything, you know, the help is there. And we use drop NA and fill NAs. Instead of doing all that from the sklearn, we have all the imputer, simple imputer. We can input and create and fill the NA values, as we have seen here. So thank you so much for watching. I believe it was easy to follow. Thank you.